Welcome to the virtual tour of the NRCS Livestock Management Watering Systems demonstration site at Ag Progress Days. This demonstration site was sponsored by USDA Natural Resources Conservation Service, and my name is Pete Vanderstappen, the state engineer with NRCS, and I'll be your narrator for this tour. This demonstration site focuses on watering systems for livestock at remote locations. These are less conventional water systems that do not rely on electricity from the grid or gravity flow. The purpose of these systems is to provide a way to get water to animals while avoiding direct access to streams, ponds, or in remote areas without surface water and electricity. So the three systems we're going to take a look at are nose pump, a solar pump attached to one or more solar panels, and a hydraulic ram. The simplest system is a nose pump. The nose pump works by using the action of pushing a lever via the animal's nose to pump water into a small reservoir. So the nose pump is drug over adjacent to a stream, small channel, or pond, has a 20 to 30 foot hose that's dropped into the water supply. Now the animal can walk up to and very quickly learns how to use its nose to push the lever forward and get a small mouthful of water, and doing it several times is able to drink water. This is great for a few animals. If you have multiple animals, you'll just need to have several nose pumps to have that action work. The second system we demonstrated at the site was a solar panel and pump. So the solar panel array is shown on the upper left-hand corner there. We have two panels there. Those panels generate a direct current, and that direct current is used to power a submersible pump. In the center picture, you can actually see that submersible pump laying in the watering trough. So basically here, we're just pumping water out of the trough through the pipe and circulating right back into the trough. In the lower right-hand corner, you can see the actual demonstration of a watering trough in the watering system that's attached to it. But let's think more about the typical layout for a complete solar watering system. On the far left-hand side, you'll see several panels, and the number of panels will depend on the lift, the vertical elevation we need to lift water from out of the ground, typically in a well, to the surface, and then from that surface up to some temporary storage point up the hill. So typically we could have 100 to 200 feet of vertical lift needed. That vertical lift, the size of pipes, etc., are used to calculate friction loss and total head requirements. That size is the pump required, and that in turn determines how many solar panels are needed to generate the amount of direct current needed to operate that system. The key part of the system here is by having a storage tank up the hill, we can now store water, and typically we store water for at least 3 days. Just in case we don't have any sun for a day or two, we have at least a 3-day water supply for the animals that are being supplied water to that pasture complex through that system. The other option is to put a battery backup system with the solar panel. So when the sun's not out there, the batteries can actually drive the system, energize the pump, and pump the water. However, that typically is much more expensive than putting a tank in there with a 3-day reservoir. Here's an example of an actual installation. As you can see in the upper left-hand corner, there's 5 solar panels on that particular site, and a detailed picture in the lower left shows there's a well casing there. So these solar panels go through an inverter and drive a electric pump located at the bottom of that well. That water is pumped out of the well and up the hill to a 3-day reservoir, and from that point the water can flow down as needed down to a trough. In this particular example on the lower right is an example of a trough at that facility. Notice the trough is located between 2 fences, so animals can access from 2 different paddocks, and that little yellow device in there is a low pressure float. So once the water is drawn down and fills back up, the flow stops until animals need more water. It's also hooked up to a frost-free hydrant so that in the wintertime, when the system's not in use, one can drain everything out and move the tub and store it for the wintertime. The last thing we want to take a look at is the hydraulic ram pump demonstration. So there's a lot of stuff on this photo. Notice in the blue circle area, you'll see a ram pump. That's the white device there, and we'll talk about that in more detail. Part of the ram pump is what's called a dry pipe. That's the horizontal pipe going back out the picture from the water supply to the actual ram pump. At the demonstration site, we actually use a tank, put some water in there. That water is what goes down to the ram pump, and when the ram pump does work, it actually pumps water, about 20% of the water, back up to the tank through a small garden hose. We'll get into some more details here in a second. So the typical situation for a hydraulic ram, starting at the far left, is to have a supply. It could be a pond, could be a stream, or some other water source, and in that water source you have a dry pipe. So that's where the inflow water flows down the dry pipe. You typically need to have 7 to 10 feet of vertical drop in order to have enough pressure caused by the movement of water to actually make the hydraulic ram pump system work. So you need to have a certain amount of fall to make this system work. But with this system, with 10 foot of fall, you may be able to lift 20% of the water coming through the system up another 100 feet in elevation. So the water that makes it through the hydraulic ram, that it's actually pushed up through the delivery pipe, goes up to a holding tank, and that could be up to 100 feet or more above that. We have specific design table charts for different hydraulic rams on how to size those things. So your next question is, how do these pumps really work without actually using any electricity or energy? Well, let's talk about that. On the left-hand side there, on that detail, there's two main features on a hydraulic ram. There's the waste valve and there's a pressure tank. So the water's coming from the left-hand side into the waste valve, and the valve in that waste valve is initially open. So water starts flowing through that. At the same time, the valve for the pressure tank is closed. Once enough water starts flowing through that, it actually shuts the valve in the waste valve, shuts that off. When that water shuts off, the water's still trying to flow. It causes what's called water hammer. That resulting water hammer, when B closes, causes a pressure spike. That pressure spike is enough to open the valve that goes into the pressure tank. And water is starting to be forced into the pressure tank. While that water is being forced into the pressure tank, in that same area there is air. That air gets compressed. It's put under pressure. Back to your left detail there. When that water hammer actually happens, it causes a shock wave, and that energy is dissipated going back up the supply drive pipe. That process, the shock wave, actually stops the water flow momentarily. At the same time, all the valves, that causes a pressure drop, so now the valve at C closes. Since some of the air was compressed in the chamber there, it now starts pushing water up the delivery pipe up to where we want to go. Like I said, about 20% of the water can move through this system. That shock wave, once it reaches the end of the dry pipe, causes a gasp at the far end of the dry pipe. That causes a pressure drop in the system. That pressure drops to the point where the valve at B opens again, and now water can start flowing out of the waste valve. That process starts over. This whole process takes about 1 to 2 seconds. It keeps repeating itself. In the process, you can pump about 10% of your water up the hill, 10 to 20%. So in summary, we took a look at a nose pump system for a very few number of animals, solar panels to supply electric to a pump, typically used in more remote locations where it's not economical to bring in typical grid electrical power. And the hydraulic ram pump system is typically for more remote locations and smaller animal numbers. Anyway, if any of these things tweak your interest, why not contact your local NRCS field office at office.usda.gov, or for more assistance, or go to the website www.nrcs.usda.gov. Thank you and have a great day.